Hi, this is David Schlesinger, and for my critical thinking project, I would like to discuss a real-life application that I am dealing with at Hilton. A little bit of background is in order here. We have deployed some software created by IBM called Rational, and within Rational, we have a number of pieces of software that do different things. And here's kind of a high-level summary. Now, this is all software that helps us manage the development of software within Hilton. So software development all starts with requirements management. This is where we gather and document requirements, and they become the source of all our designs and all of our tests. So Rational Requirements Composer is the software application that we use to do this requirements related work. Then we use another application called Rational Team Concert, and as you can see, Rational Team Concert performs two functions. One of them has to do with change management. So as we make changes to the system, those changes get documented and they get driven by work items in Rational Team Concert. Now there are other pieces of software like quality management, which is used for testing, and architecture management, which is used to further document our designs and create models. So these applications here are used in varying degrees at Hilton. But within Hilton, everybody uses Requirements Composer and Rational Team Concert. The way the Rational software is licensed to us at Hilton is based on a floating user concept. You really have two ways you can license this software. You can either go with a named user, which means that you're buying the software on behalf of an individual user. So if you have 100 people who are going to use the software, you'd buy 100 licenses and assign a license to each user. Or you can go with a floating user concept, which means the users aren't named, but the number of licenses you buy determines the number of people who can simultaneously use the license. It's almost as if anybody can use the software, but for each person that uses the software, while the software is in use, he's checked out one of the keys. So if you see, for example, with Rational Requirements Composer, we have a total of 96 licenses available. That means if 96 people are using it at the same time, and a 97th person tries to use it, they'll get locked out and they won't be able to use it. So our challenge now becomes figuring out the right number of software licenses to buy so that we very rarely, if ever, have people locked out of using the software, while at the same time we don't spend too much money on this software, more than necessary, because the software is quite expensive. For example, Rational Requirements Composer costs about $8,500 per floating license. So as I said before, this analysis is going to look at the two key pieces of software that we use all across Hilton, Rational Requirements Composer and Rational Team Concert. When we first bought this software from IBM, they gave us some standard formulas about how much software we would need to buy depending on the number of people that we have in various positions. So based on the number of analysts and developers that we knew we had, this ends up being the number of license keys that we bought. Well, it turns out for the most part that was way more software than we needed. And so my objective in this exercise was to develop a model that would help us predict how many licenses we would need. In order to do that, we've been gathering utilization data over the course of this year. The two pieces of utilization data that we gather are the maximum number of users at any given point in time during the month. And that is to say that, for example, in January of 13th, we've never had a situation when more than 18 people came in to use RRC Analyst at the same time. So you can see that number is way under the number available of 96. And with respect to RTC Developer, we can see the biggest simultaneous usage we had was in February, which was 56. But for most of the year, we're way under the number. Then in March, we started tracking the number of different users who use the application. So as opposed to peak users, this number here represents the number of unique individuals who at one time or another during the month use the application. So what we're trying to do is get a sense of our overall user population and what level of peak utilization that drove. And my goal was to try to develop some predictive models that, given the number of unique users, maybe we could figure out the number of peak users so that we could keep under our maximum available, but without having to maintain more software licenses than we really need. Another relevant piece of information that I was able to gather centered on the number of projects that we had going at Hilton at any given time. So this list over here tells us about the projects that got kicked off in any given month. And as you can see, we've got a count of projects that got started in any given month. And then I made some assumptions around average project length so that these numbers would be cumulative for an average of 4 months, meaning after 4 months, the earlier projects would start dropping off. With those assumptions in mind, I was able to build the following tables. This summary table shows, for the period of January through October this year, the number of projects that we started in each month, the number of active projects, and you can see that these are cumulative until after 4 months, where because of the average span of a project, the earlier ones start dropping off. So this column, column C, gives us the active number of projects. And then I just took the unique and peak usages of RRC and RTC. I also did it for RQM here, but I'm not going to include that in the study, again, because that is not used all the way across Hilton. And now for the analysis. First thing I want to do is look at RRC, and I'm going to compare RRC peak usages to the number of projects started in a month to see if there's any predictive value there. Using the trendline function and going to more trend lines and predicting linear, you can see that the line is flat and the R squared value is near 0, so there's no real value in looking at linearity here. Likewise, looking at a power plot, we don't get any improvement on the R squared either. Exponential is a poor predictor as well, and as a matter of fact, what we're seeing is RRC peak users going down as more projects get started, so we know that's not right. Logarithmic, likewise, does not seem to be useful at all. And while polynomial gives us kind of an interesting pattern, it suggests that as more projects get started, peak users roll off, and that also tells me that there's not a really good relationship between project starting and peak users. The next thing I want to take a look at is the total number of active projects versus the RRC peak. And here we see an R squared that, while it's not high, it's certainly a lot higher than what we saw before. And given that we've got some outliers and anomalies here, I may not really be able to expect a very high R squared. What's kind of interesting here is that the more projects get active, the more users get added. And then as more projects come on, the number of users starts dropping off. And that could very well be because I don't have a very good assumption around 4 months per project. So I went and changed the average project length to 6 months. So you can see that over 6 months, the number actually increases by the number of projects added each month. And only after 6 months instead of 4 do the original projects start dropping off. Now what this does is it produces a more realistic curve in the polynomial analysis. When I say realistic, it means it doesn't start going down like the other one did. So now what we're seeing is the following effect, that as projects increase, the users increase, but at a tapering rate. And that's because as some of the projects get old, while there are still some users in, they may not be as active as before. And you also have the same users rolling from one project to another. If you have the same people working, then you don't increase the number of peak usages because each user only grabs one license at a time. So this ends up being a more realistic model in my opinion and based on my experience. So what I did is I took the B2, B1, and B0 values from the resulting equation, and based on the project load for 2014, we're going to get the following predicted usage values for RRC. And these usage values look to be very realistic to me, and they also tell me that I'm going to be way under my license count, so no need to increase the number of licenses, and we may even consider releasing some of these licenses even though their procurement is a sunk cost, there is a 20% annual fee on maintaining these licenses. Now I'll do a real brief summary on Rational Team Concert, which is the other piece of software we use. Its usage is much more efficient because typically Rational Team Concert user will come in and do a relatively quick task and get out. So you get lots and lots of people being able to reuse licenses, as opposed to Rational Requirements Composer, where people stay in for a long time each session because they're writing requirements. But the best model we could get is a polynomial model, and this is if I'm looking for project started versus peak. So that relationship is not going to be a really good predictor. Likewise, for active projects versus peak, you can actually see that the numbers going down, so that doesn't make any sense at all. It turns out the best model I was able to come up with in terms of an R-squared was a polynomial again, where I was looking at unique users to predict peak users. And you can see that it kind of trails off, and that's not entirely surprising because as we add more and more users, you have other people whose involvement in projects may be trailing off, and therefore they don't come in as often. So even though they may come in from time to time, that doesn't drive the peak. Now I use the formula that I took from here in order to make predictions for next year based on some sample users, and those numbers will have to be validated by interviewing the departments. But as you can see, the predicted outcome looks fairly linear, and that's certainly a predictive model that I'm comfortable with. And once again, what it tells me is that I have ample licenses for next year. So here are the conclusions for my critical thinking project. Number one, we have a relatively small amount of data to work with. That means that no analysis is going to be all that accurate or all that good. We've only been polling usages for 10 months and unique users for 7 months, and there are probably a good number of other factors that are just simply not even in the model. So as a result, we didn't get any regressions with very high R-squared values, but the best ones we got were based on using unique users to predict peak users, and we got reasonably high enough R-squared values there that I'm certainly comfortable that we have enough licenses. And as a matter of fact, we could consider dropping our requirements composer licenses from 96 to 60. And even though the model says we need 31 licenses, so 60 is nearly double, that gives us plenty of margin for error given the relatively low confidence level of the models. Even if we did that, we would save over $60,000 in annual operating costs. So I'll have to say, despite the dearth of available data, the analysis tools I think were useful, and they've given me some indication that we can do some level of prediction, and they've certainly given me a level of comfort around the number of licenses I've needed, and this is a great improvement over simply relying on the vendor's estimates as we've done in the past.